Hello students, this video is about translations and rotations, so let's jump right in. Translations first. A translation is a shift or a slide, and so a translation takes your original thing and it moves it over. Okay, or it could move it diagonally, but after it moves it's the same shape, only it's moved over. Now translations can be described by a vector. Okay, a vector that which tells how much to move in each direction. And how you know it's a vector is instead of having parentheses on the side, it has these arrows on the side. So these arrows here are what lets you know that it's a vector and not just a point. So, for example, let's see, what would the image, find the image of Z. Under the vector, I can tell it's a vector because it has the arrows 3, -2. Well, here's the point Z. This 3, the first number in the vector, tells me how much I should move in the X direction. And the -2 tells me how much I should move in the Y direction. So this tells me about the X, and the -2 tells me about the Y. So I'm going to start at where they tell me at Z here. I'm going to start at Z. If I start at point Z and I move 3 in my X direction, +3. So here's my X axis, right? So X is this way. So starting here I'm going to go 1, 2, 3. And then I go down 2 in my Y direction. 1, 2. It looks like I end up right here on point Q, because from here I come over 3, start here, it would be like 0, move 1, move 2, move 3, then starting from here, move 1, move 2. So where do I end up? The answer is I end up at point Q. And so on the homework sheet there, I want you to tell me if you start at whatever point they give you, where do you end up? Where's the point where you end? You can also say what vector you've moved. Now, next example, find the vector that describes the translation that takes M, and this arrow means we're moving from M to Q. So what is the vector that goes from M to Q? Well, here's point M. If I start from point M, I'm trying to move and end up on point Q. How would I have to move to go from M to Q? Well, I'll start with how much I have to move in my X direction. It looks like in my X direction I need to move over 1, 2, 3, 4. So I need to come over 4, and then I need to come up 1, 2, 3, 4. Over +4, then up +4. So my vector is the vector that has +4 in the X direction and +4 in the Y. This is the vector. And remember, when you're writing your answer, don't put commas on the sides, because we're not talking about the point 4, 4. We're talking about the vector that moves over 4, up 4. Okay, you can also write translations as a matrix, okay? So you can take the point and take the point that's written X, Y, and write it in a matrix like this by putting the X on top and the Y on bottom. So let's look at this shape right here. First, we need to find out where all of these points are that make up the vertices. Okay, so go ahead and count where each of the points is located. Now, we can take all of these points, and instead of writing them like this, we can make a matrix out of them. So we're going to take each point. The first point is -2, -1. I'm going to put -2 on top and -1 on the bottom. And this point, put the 0 on top, the 1 on the bottom. This one is 2, 1. This one is 4, -1. And close matrices. So the first step is to make a matrix of the points. So here's a matrix of all the points that were in my graph. The next step is to make a matrix of this translation, -3, 4. Well, I only have one point, right? I need to be able to add this to every one of these so that I can shift the whole thing. So you're going to have to make a repeated matrix. Repeat -3 over 4 4 times because there are 4 points. Okay, there's my translation matrix. Now, what we're going to do then is just add these matrices together. So when we add them together, we're just going to add every number that's in the same spot together. So I've got in the upper left corner here, I have a -2 and a -3. So -2 plus -3 is -5. Below that I have a -1 and a 4. -1 plus 4 is 3. I have a 0 and a -3, that's -3. I have a 1 and a 4, that makes 5. -2 and 3, 1, that one's 5. 4 plus -3 would be 1, +1, and 3. Okay, so this is our answer, and now we can just graph those points on here to see where it ends up. The first point would be -5, 3. The point -3, 5, the point -1, 5, and the point 1, 3. So now I'm done. And last, let's talk about reflections. So, a reflection is like your face in the mirror, right? You see the reflection image of yourself. It looks the exact same as the other, only now it's kind of been flipped over. Okay, so when you're doing reflections, I want you to do first is draw in that reflection line. Now, where does that line go? If you have x equals, that means that you're going to have a vertical line, okay? A line that crosses through the x-axis. And if you have y equals, that's a horizontal line, okay? A line that crosses the y-axis, that crosses it. All right, so let's look at this first one. Let's draw the reflection line. A line over, and we're going to see if we can reflect over x equals 2. Because I have x equals, I know I'm going to have a horizontal line. So I'm going to come to my x-axis. Here's my x. Up here's my y. Okay. I'm going to come to my x-axis, and I'm going to find the point 2. 1, 2. Okay. There's the point 2. Now, I'm going to draw a line that crosses the x-axis at that point. Okay, because it says x equals, I need to cross the x-axis. So I'm going to cross the x-axis like this. Okay, my marker is dying, but hopefully you can see this blue line right here is the line x equals 2. Now, what you're going to do is you're going to move each point to an equal distance on the other side of the line. And the key words here are equal distance. However far it is on one side of the line, you're going to make it the same distance on the other side of the line. So, this point right here, it looks like right now, how far is it from the middle of the line, from the line? It is 1, 2, 2 spaces over. So since it's 2 spaces on this side, I need to come 2 spaces on the other side. Okay, so 1, 2, 1, 2, right here. Equal distance. So now down here, this point is directly on the line, so I'm going to keep it right there. It's not going to move anywhere. How far away from the line is this point? That point is 1, 2, 3 spaces. Since it's 3 away from the line on this side, we're going to make it 3 away on the other side. So now I've got my new points. I can just connect them to get the triangle. Now let's see if we can reflect over the x-axis. Alright, now this time I don't have x equals. It just says x-axis. Well, the x-axis is right here. So if I were to reflect over the x-axis, I'm reflecting over this line. So, how far away is each point from that line? This point is 1 above the line. So I'm going to come 1 below the line. This point is 1, 2 above the line. So I'm going to come 1, 2 below the line. And how about this one? This one's below the line. This one is 1, 2 below the line. So when I reflect, I'm going to come 1, 2 above the line. And this one down here, this one is 1, 2, 3, 4, 5 below. So I'm going to come from the line, starting from the line, 1, 2, 3, 4, 5 above, and connect my points. And there is my reflection. That one's kind of cool because it overlaps. All right.